Hello, future me, or future anybody else who's watching this after I record this video. I am going to be working through a project, the most complete starter kit Uno R3 project. I really have no idea what's entailed in all of this. All I know is that it's a gift that I got last year that I wanted to work through because I wanted to do more electrical engineering stuff as a hobby because I am an electrical engineering student attending the University of South Carolina and about to graduate, but I don't really do a whole lot of this stuff as a hobby, so I figured I should do more stuff as a hobby. And I wanted to record it so that way, one, I could look back at what I was doing and what I've done so I could maybe retrace my steps if I need to, but also so that way anybody else who does this particular project can see my own mistakes and I don't know. If I get caught up in particular places, maybe you can also do it. I don't know. It's also just maybe a fun little thing to just sit down and record so that way I can look back and see all the progress. So you can see here in the kit. I'll have to just grab that webcam. Let's see here. Alright, so there's the kit. There's the box. It comes with, what do you know, a CD. Even in 2019. I think that's a little ambitious, maybe. A little optimistic that somebody's gonna have one of those. But also still good to have physical media, right? Alright, so let's see here. We got a whole bunch of stuff. Here's a microcontroller, little proto boards, bunch of resistors, lots of different cool stuff. Let's see. We got a propeller over here, so I guess it gives us some idea of what this is going to be. And there's a bunch of LEDs and semiconductors in that box right there. You can see up here, it's got all of the components that you're going to have. So, I guess, let's get to it. Alright, so, you don't need the CD in order to get the tutorial for how things are going, because you can see it down there at the bottom, that you can get the tutorial online. So, let's go there. Let's see here, we're going to start that virtual camera so we can get the webcam. Is that what the virtual camera is? I don't know. Let me pause and figure it out. Well, that took me a sec, because I had to figure out how the OBS software works, but here we go. I finally figured it out. Yeah, so for anybody who's trying to use OBS to capture anything, you have to have display capture set up here in the sources. To put it up there and specifically check the screen that you're using, as well as the, I don't know, you have to give it a name. Alright, so let's see here. So I had said that I was going to do this all, show the whole process of me redoing this, recording this whole thing. So let's see here. lu.com/download. Alright, let's see here. So I've literally not looked at this at all. Okay, so 3D printers. I'm guessing this is a STEM kit. Basic starter. Yeah, there we go. Here, we'll go to the tutorial. I already have Arduino IDE. Okay, here we go. Here is the tutorial. Packing list, very good. You know what? I guess let's go ahead and go through that. So, certainly have the Uno R3 with USB. USB is over here. So we got both of those. Tilt ball switch. there's some servos. Not what I'm looking for at the moment. It's always good to look at stuff ahead of time so you know exactly what they are before you actually really need them. I got a whole bunch of the motors and stuff. It's probably all in here. Yeah, this is the stuff. Let's see here, tilt ball switch. I feel like that's a... Is that not just a picture of a capacitor right there? I mean, I guess not. It's saying it's not. Sure does look like a capacitor. Oh, is this it? See that HDX logo on the side. Are you... Oh, I think that's the one. You can... I don't know if you can hear that. Literally, there's clearly a little ball that's in there. I guess that's why that's the tilt ball switch. Yeah. Get my face out of the way. So you can see that up close. Yeah, well, maybe you can hear it. Okay. So let's see here. What else do we need? Not that. Okay, we got a whole bunch of LEDs. We got all those LEDs right there. In the top section of that thing. Okay. Active buzzer. Yeah, we sure do have an active buzzer. We should have 5 buttons, and I can see them right in there. And that 1, 2, 3, 4, 5. Got those. All right, we got this wire right there. So first, we got the whole 65-piece bundle wire right there. I'm gonna trust him. Don't feel the need to count that out. FM DuPont wire, 5 pieces. Well, we certainly have more than 5 pieces in this, so I'll take that as a plus. And then breadboard. Okay, there we go. That's the real one. Ooh, hey, number pad. That's a good one to have. That's on the list. More resistors. Sautos breadboard. Very good. Put those things back where they came from. I wonder what this thing is. That's all the things. Oh wait, so the 74HC. That's a. Op amp? No. How would you have used you before? Let's see, L293D, which is on this one, I believe. Yeah. Alright. Oh. I didn't show any of those, did I? Yeah. Alright. Here's that big bundle of wires. The what I referred to earlier is the FM DuPont wire. All connected together. You got the male end on that side and female end on that side. A whole 65-piece bundle of wire. The Uno R3 microcontroller. The LEDs all up there. And then here should be that 74. That's the L293D. Yep, there it is. 74HC. Wonder if I put this lamp down a little bit more if it'll actually focus on it. The sun. No, I don't know how cameras work. But that's it. It's in the top right corner of the flip-up box. Alright, now, let's see here. So we also have these ultrasonic sensors right here. Something that I'd failed to use for another project where I tried to make a quadcopter for my class. Didn't quite implement it. Oh, I got a joystick cover, which means we also have the joystick itself. Probably goes just on top of that, doesn't it? Yeah. Oh. Okie doke. We've got. Oh. Gotta put that back on. We have a 7-segment display. Yep, so that's that thing. Let me just pull this back here so you can see where this is all coming from. That's where the 7-segment display comes from. This right here. I wonder what this thing is. It might be that 5-volt relay. Yeah, it looks like that's exactly what it is. It's that thing right there. Okay, so we've got a relay here. Got this pink thing. Oh, tiny little 7-segment display. Only 1 segment. See right there. 1 segment and the 1-digit and 4-digit 7-segment displays. There's that 9-volt adapter. I realize I'm going the wrong way here. Okay. Uno board, LCD module with pin header. So we've got an actual LCD screen. Is it this one? No, it's not that. Let's see. Oh, here it is. It's under the remote in the top left corner of the box. Yep. Bunch of styrofoam for ESD controls. Overtap expansion module, which is, yep, it's this. It's got a breadboard on top of it, so integrated with that expansion. Power supply module, right there. I'm guessing that's a gyroscope. I'm guessing that's what the GY stands for. So let's see here, GY 521. Let's see, what's this one? This is Do you all see it? Okay. Does this look like anything? Okay, come back to that in a bit. This thing I can see is the sound sensor module. Came right here. See it up there. Okay. This thing, what is this thing? It's got a little disc on the back. Okay, so this is the DS1307 RTC module. And right here. Same container as the sound sensor module. Alright. The rotary encoder module. This. It's got the really tall switch. Well, rotor, I suppose. Okay. We've got a temperature module. Excuse me. Okay, right there. Got that funny blue chip on it. IR receiver module. Looks like they put that in the same bag as the rotary encoder module. It's right there at the bottom. Joystick module, we already played around with that. We got a remote control right there. Ooh, and I forgot to make note of the water level detection sensor. Okay, so I'm guessing we got a lot of different things. We got a sound sensor, water level detection, ultrasonic sensor. This is a whole grab bag of stuff. This is going to be fun. Alright, let's see. Max 7219 module. Guessing those are LEDs that are going to light up on that. Went through the 7-segment displays, went to the L293D, the 74 H59, the active buzzer, yep, we looked at that. Passive buzzer, that's the other little disc that was in here. Alright, so these are the buzzers. Those are the dip packages, dual inline pin package, because they've got 2 lines of pins. Potentiometer. Is it potentiometers? No, that's not potentiometer. Where's the potentiometer? It's a tall one. Oh wait, no, these are the potentiometers. That just fits into there. I got that's the actual dial that fits into that. We'll get to that. 5-volt relay, we already looked at that. That was the big blue thing right there. Fan blade and the motor. So I think that's the motor. Is that the motor? I guess it is. It just doesn't look like the one picture. So fans, motors, fans are over there. Alright, then we got the membrane switch module. With the breadboard, we looked at that box earlier. It's here in the bottom right. 9-volt battery with snap-on clip. So there's the 9-volt battery. Batteries included. And then the clip. I kind of talked to the side earlier. Oh, no, that's another one that I got. That's my personal. This one is a nice one. It's got the connector at the end. So I guess you could. Oh, obviously not for charging, so you can power whatever you need to power. Okay. Then the adapter, jumper wires, DuPont wires, USB cable. So the board can talk to the computer. 120 pieces of resistors. Fantastic. Thermistor. That's obviously going to be in here. If we have a thermistor, surely we'd have a thermoses. Alright, let's see here. So that's obviously a photovoltaic, you can tell because of the printing at the top. Okay. So that's, yeah, there we go. Photoresistor right there. There's 2 of them. Sure enough, here's the other one. That thermistor has a distinctive kind of like U shape at the top of it. Should be relatively easy to pick out from all the capacitors. The ceramic one specifically. Oh, there it is. It's underneath the buzzer. You can. Sorry, I wish I knew how to make a camera focus. Unfortunately, I do not. This isn't me needing to make you trust me. It's me needing to verify for myself. Yeah, that's it. Thermistor changes resistance as it heats up. Okay, diode rectifier, we got 5 pieces of those. And you can sure enough see them. I'm not going to pull those out. Okay, but they're in the bottom left there. 100 microfarad electrolytic capacitor. We got, it says we got 2 of those. That's going to be the bigger ones, right? Yep. There's 1. There's 2. 10 microfarad electrolytic capacitor. 2 of those pieces. Those are the slightly smaller ones right there. You can tell because they say 10 microfarad. If you turn it around, yeah, there you go. If you're able to, if I back up, you can see that. But zooming in, I don't know. There's 1. There's 2. NPN transistor. Yep, we got a whole bunch of those right here. So there's the PN2222 as well as the PN2222 as well as the S8050. I don't know what the differences between those two of those are, but I'm sure we'll look it up. We'll find a data sheet later when we're doing the project. What does that say? Yeah, that's 8050. So there should be 10 in total. I'll trust that they put 5 and 5. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, we got 10. Now the tilt ball switch we found earlier, played around with that. There's an actual ball inside there. 5 buttons, counted those earlier. Red LED, yellow LED, blue LED, green LED, white LED, RGB LED. You can tell that's got 4 pins on it. So there's 5 of the other ones, which, yep, sure does look that way to me. But then the RGB ones, right there, see they got the 4 pins on them. I don't know, I think pins is the wrong term. I don't know why I'm saying pins. It should be something else, but that term is escaping me right now. Okay, then we got a bunch of capacitors. We got 5 of the 104 picofarad ceramic capacitors, 22 picofarad ceramic capacitors, so 5 pieces of those as well. All those we got here. So you see we got big ones, we got small ones. Small ones are obviously the smaller ones. This is going to be hard to see. So in case anybody's learning how to read ceramic capacitors from this video, so you can see that one says 22 on it. You probably can't see it, but if you pull it out, it says 22. Whenever you have a ceramic capacitor with its marking, because they're so small, you have to be very limited in space. So they assume it in picofarads, because picofarads pretty much as small as you're going to go. So if it just says 22, that means 22 picofarads. Then if we get out the other one, which is 104 picofarads, should probably just say, yep, 104. Maybe you can see it, hopefully. From there. No? Just gonna shift the colors green. Okay, it says 104 on it, which is actually pretty easy to see if it's in focus for you. But once you start going higher than that, then it actually starts adding on the scientific notation. But it looks like we don't have to deal with that here, so I'm not going to go into it because I don't have an example to look at. Okay, but we got all our pieces. That's great. Step 1, as always, make sure that you got all the things you're supposed to get. And it looks like we got a little something extra because I'm not sure what this is. It's not the gyroscope module. I see GTY on here. I guess I just got an extra little thing. Oh, no, there it is. It's in the upper right corner. I skipped over it. So we have the servo motor. I guess I skipped over this entire row. We got the servo motor right there in this bag. Stepper motor is right here. And then this is the stepper motor driver module right there. So that's what that is. So now it gives me another kind of question though, because here was the fan, but that's supposed to come with its own 3 to 6 volt motor. It's supposed to have another motor in here. Did I take it out already? Because there's this whole, I did take out this RFID chip. Oh, here it is. There it is. There's the stepper motor. And then, I guess they just, this RFID thing does actually seem like it's extra. I don't see it on there. It's probably just didn't put it on there, but it is, I'm certain in the project manual. So let's put all this stuff back as neatly as I can manage for right now. And I guess let's get on with some more stuff. Alright. Yep, we got it. We got it all. Okay, so lesson 0, installing IDE. So, yeah, here's the thing. I actually already have Arduino installed on my computer, but this tutorial page has something very helpful. You can just click there, go to the software. As you can see, their tutorial is a little bit old because we're on 2.3.4 right now, and they were still on 1.8.0. So that's part of the joy of doing this project, because if there's anything that changed in between the two, I can figure it out for you. Or maybe just for myself. I highly doubt anybody's going to watch this. Okay, let's see here. Right, so I already have that on my computer. Yeah. Download the development software. That is yes, of course. Okie doke. This is all the instructions. It's going to walk you through exactly what you need to do to install Arduino. Okay, so let's see here. Okay, but this is an important part right here. So this was just installing Arduino, and this is now installing the actual drivers for the board. So what it is telling me to do, gotta actually get the Arduino board, our Elegoo Uno R3. I have to open this up. I should be taking more precautions, I think, probably with ESD. Well, I'm not on a very conductive surface. Seems like there's relatively low humidity in the air. Or high. 50% humidity is what you want. So we got that open. You want to be very careful. I suppose you don't need to be very, very careful. The box says this is recommended for 8 and up. So if this was really that sensitive, probably wouldn't be recommended for 8-year-olds. So we'll just take it, grab it from the sides. You don't want to grab the pins. And we'll set that down on the packaging itself. Now let's take our USB cable right here. We'll plug this into the board, because the computer, my laptop, still needs to be able to download the drivers, little bits of software that lets the computer talk to the board. So we got ourselves this basic serial connection right there. I'm sure somebody doesn't like the way that I'm putting this in. That person is me. I hated the way that I put that in. Alright, so now I'm going to plug that into the board. Computer, excuse me. Alright, there we go. So it looks like you should see a green light come on and a yellow light flashing there, the L1. It's probably right through a manual. So that probably tells me that it's waiting for a signal, and that means that the board is on. So, let's see here. Yep, it says that on here. It says power light and the LED will light up and you may get a found new hardware message from Windows. I think you probably heard that notification. Ignore this message, cancel anything, blah blah blah. This acts in different ways. Okay, the most reliable way of installing the USB drivers is to use the device manager. So it recommends that. I always just press the Windows key and then start typing. Type it and click enter. And there we are. So let's see here. Under other devices, you should see an icon for an unknown device with a little yellow warning triangle next to it. Other devices? Maybe that's Bluetooth peripheral device? That's what, no, that's certainly my phone. Let's see here. Maybe it already knows what it is. It certainly doesn't have an unknown thing. Oh, there it is. Arduino Uno. Okay, Windows will grab the drivers already. Ah, but we gotta get them from Arduino. Okay, well, wait a minute. I guess we can make sure that we've got them. Update the drivers. We'll search automatically. Okay, cool. Best driver's already installed. If you want to do it on Linux because, I don't know, you're a superior human being, you can do it right there. Alright, add libraries and open the serial monitor. Okay, so I'm going to open up my Arduino. Loading, loading, loading. Alright, let's put that. That's another project that I'm working on for university. Okay. Okay, so libraries, those are the things, the little bits of code that make it easy for you to code, so you don't have to deal with a lot of in-depth stuff. So here's how to use the library manager. Are you telling me that I need to get a library manager? Okay, we're going to install the bridge library. Okay, so we're going to come over here. This is the library button. Looks like a bunch of books stacked together. Add something in. It wants me to add something called the bridge library, so let's search bridge. Yep, there we go. Bridge by Arduino. Oh, didn't need that. Okay, well, we'll go ahead and install that. It says between Linux processor and microcontroller. Not sure. It wants me to get the Linux. I'm not running on Linux. We'll go ahead and download audio because it looks like. Yeah, we'll download audio because I'm probably going to be using that. Alright, download audio. Audio by Arduino. Okay, anything else that it recommends downloading? Includes a whole bunch of other ways to add your own libraries if you find something online that you want to use, either through GitHub or through this. Okay, Arduino serial monitor. That's part of why we're using this, because we want to be able to see what the Arduino is saying and thinking and printing. So, yeah, we can go ahead and click the serial monitor right up there. Let's see, we got to select a port. So we want to come up here to tools. And this is where we got to select the board, right? Let's see what it tells me to do. We'll just go ahead and select the port for that. Yep. I don't know why it would be telling you to do this first, because you basically should see nothing. Yes, good. Blank thing. Okay, obviously it recommends using 9600 baud. You know what? I'm going to look up baud. Because whenever you establish a connection with a serial monitor, you select this big old number right there, B8, and then this word, BAUD, baud. I have no idea what that is. Let's look it up. What is baud rate? I'm not fully trusting of AI yet. Like, is it right? How can I confirm it? The only way to confirm it is to go to the website. Okay. Like, I don't know. I don't know who Nico Fongchit is, but I trust them more than whatever just popped up at the top of Google, because their name's attached to it. Okay. Baud rate is commonly used when discussing electronics. Okay. Supported cable is transferring maximum of 9,600 bits per second. Okay. 9,600 bits per second. Does it stand for something? Okay. So that's how fast it's transferring data. Very important to set that, because if your computer is transferring data faster than the microcontroller is ready to receive it, then it's just going to give you a bunch of gibberish text because it doesn't know how to process it. Okay. That's it? Okay. Cool. Alright, we're going to learn how to make it blink. Hello world of programming. Alright. Got rows of connectors along the side that you use to connect to several electronics and plug-in shields. Also, a single LED that you control from your sketches. That's the one that we saw blinking earlier. It's referred to as L, because that's how it's labeled on the board. Smart. You may find that your Uno R3's board's L LED already blinks when you connect it. This is because boards are generally shipped with the blink sketch pre-installed. So we're going to reprogram it with our own blink sketch. Amazing. So we found the right serial port, and now we got to put that connection to the test and program the board. Alright, so this is always the fun thing where you can get examples from all the libraries. So we're going to go to our basic examples up here. And before I get into this, let me make sure that you can actually see what I'm looking at. Okay, good. Alright, so we got File, Examples, Basics, Blink. Opens up a whole new sketch. So there's the entire thing right there, written by a guy named Scott Fitzgerald, or not written by him, modified by him at some point. And then Arturo Guadalupe, and then by Colby Newman. Amazing. Example code is in the public domain. Great. It's been modified ever since then. They just have Scott Fitzgerald. We've got Arturo and Colby on it. Alright. The example sketches included with the Arduino board are Arduino IDEO read-only. That is, you can only upload them to an Uno R3 board. If you change them, you cannot save them as a save file. That's good. Okay, so we got to save it as our own copy. Let's go save as. These are basics. Always got to save as. Okay, sure. I'll call it my blink. Why not? Here, I'm gonna make a new folder here. I'm gonna call it Uno R3 projects. Call it my blink. If you ever want to find it, you just gotta go to File, Sketchbook. There it is. Okay, so we gotta check the board type. So here is where you set the board. So we can select another board, because that's a different thing that I'm using. So there's COM7, that's where our Arduino was. So let's see here. Okay, Arduino Uno. Can I get the R3? Do I need the R3? I'm guessing no. So we'll just take the Uno. Oh, hold up. Board. Arduino Genuino Uno. Okay, so let's look at that. Okay, so the boards manager. Uno. Let's see, what are the boards included here? What? That didn't take me where I needed to go. I want to make sure I'm using the right thing. Okay, that's great. Let's see, where are the files? Okie doke. Yep, there's the Arduino board packages, the Arduino core, so no additional necessary to use a different version than the latest of the board manager from the left-hand manual. Okay, so we're just using the AVR board package, which is already in. Okay, so we just need Arduino Uno on connection 7. Okay. There we go. Arduino Uno on COM7. Okay, so we're going to upload this blink thing right here. Click this arrow right up here. Compiling. Failed to upload. Oh, did I choose the... Set to the wrong thing, isn't it? No? Access is denied. Now, why is access denied? Sorry, let's see what happens. Do I need to press a button here? Okay, so there's a red button on here that I'm gonna press. This is exactly why. Right here in this up corner, I'm gonna see what that does. First of all, it's making that thing turn on. Making the one LED. Okay. So let's see if that helped to reset anything. Do I need to hold the button down? No. Okay. Okay, okay. Ah, I did not have the USB plugged in all the way. So then, wait. Certainly I did. Okay, so is this... Yeah. Needs to be the Uno. Okay, okay. Well, let's figure this out. Copy paste that error message. Okay, so he's getting the same thing using Windows 10. There's a bug in 1.6.8 of the IDE in Windows that can cause access denied errors when trying to upload due to a defect in serial port treatment. 1.67 works, and I heard 1. Okay, well, I'm not in that. Well, okay, let's first just start trying with unplugging it, plugging it back in. I'm also gonna close out of the Arduino IDE. Okay, so I'm gonna plug back in the Uno. I hope that takes care of it. Okay, updates. Yep, we gotta make sure everything's always up to date. So go ahead and install all that. Okay. Alright, let's see here. Arduino Uno, COM7. Please? No. Okay, okay, okay. Okay, well, I might need to restart the computer. So this video is going to have to end here on this. Let's see here. Upload fails if port is open and serial monitor of another window. Ah, there it is. The serial monitor is open here. So it's trying to talk to the thing while it's open in another window. Okay. I had the serial monitor opened up earlier according to its own direction. So let's see now. Does it work? Oh, yep, I think we got it. So it's compiling, it's compiling, it's compiling. Should be able to see that there. We'll let you see what's going on here. So you can see on the screen, it's uploading. We'll go ahead and make that full screen. It's connecting, bars, 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 loading, and a fatal error occurred. No serial data received. Okay, well, I'm going to try it again, but this time holding down the button. Once it gets there, we'll see. Boo, boo, boo. Wait right there. Now I'm going to hold down that red button that I showed you earlier, because usually that's the kind of the reboot or boot button. Makes the board ready. Maybe not the case for this. Maybe not. It's plugged in all the way. No serial data received. This isn't the, oh, I have the wrong board selected. ESP32, this isn't the ESP32. Let's not use that, let's use this. Uno. There we go. Okay, let's try it again. One more time. So silly. Still trying to upload to an ESP32. Is it doing anything? Did it do it? Oh. Yeah, I guess it did. Here, I can show you. Oh yeah, there's the sketchbook. Okay. So here we go. So here's the board, and you can see exactly what happens when I upload it. Upload the blink. So those two LEDs down there, that's the TX and RX, transmit and receive. They transmit and receive the data from the board. They light up to let you know it's communicating. Now it's just blinking exactly like it did before because that's all that the program did. And I can look through the code. I can kind of explain what's going on. Because all this is just comments letting you know stuff about the code, who wrote it, what it's supposed to do, right? So on the Uno, the Mega, the Zero, it's attached to digital pin 13. So that means that the LED is attached on the board to pin 13. Now, the interesting thing about this, right, is that you're looking at this board and you're like, okay, which pin is pin 13? And you can see, you're like, is it one of these pins, these things that I can actually plug into? No. What you got to remember is that this whole thing is actually just a package that helps you talk to the actual device, the actual microcontroller. The actual microcontroller is that little guy right there. It's doing all the thinking, all the brains. Everything else is just attachments to other stuff, right? So if you were to count around there, starting from pin 1, which would be probably like here on the, here on the top left, and you count down this side and up the other, you'd eventually be able to count to pin number 13. And that pin is what connects to that LED. So as far as the microcontroller knows, it only knows that the pins all around it are the ones that exist. So that's how it thinks about things. So when you look over here at the code, you can see pin mode, LED built in, comma output. So that is telling us that that tells us that we are setting up. Let's see. Runs once. Initialize the pin LED built in as an output. So it's just making sure that we know that this is going to be an output. We're going to be sending a signal to it. Okay, good. Part of me is understanding it. I'm mostly understanding it for me. Okay, so then down here we have this digital write command, where obviously we need two arguments put into it. One, where you're writing to, and what value you're going to write. That high is a logical high. That's a 1. The low is a 0, more or less. And it's got delays in between, so that's 1,000 milliseconds. So that's how we can see that the LED is on for 1 second, and it's off for a second. And this whole thing loops back around, and it stays in this loop, running over and over again forever. Okay. And that feels like a pretty good place to stop this whole thing. So, I don't know. It's pretty good. A lot of basic stuff. We have all of our things. The board is working, talks to the computer, and receives stuff from the computer. And it blinks. You know what? Let's see. Just so we can have a reference here. I'm gonna change that value in there. So that's how fast it's blinking right now. Now I'm gonna go over here. Oh, not that one. Here. And we're gonna see. Let's just turn that lower. So now it's gonna be off for only 1/10 of a second. Okay. I'll just let you see that transition up here on the actual board itself. You can see the LED blinking. So now I'm going to upload the code. There's the transmission. And there. Now you can see it's only off for like 1/10 of a second, and then it's on for a full second. So cool. Can't wait to see what other projects it has us do, because there's a whole bunch of other stuff in here, but that was walking through the tutorial of it. And what we did was go into the basic starter kit, and what we did, we took an inventory, we installed the IDE, we added some libraries and opened the serial monitor, and then we tested out the Blink program. And then the next is going to be all these other different projects, testing out the inputs to the board. So that's going to be super fun. I should come up with a sign-off thing. I don't know. No one's going to watch this. That works.